Okay, so dito tayo sa part 2, problem 1 to 3. So the weight of a certain crown in air is 14 newtons and its weight in water is 12.7 newtons. Assuming that the crown is an alloy of gold with a specific gravity of 19.3 and silver with a specific gravity of 10.5 and the unit weight of water is 9,790 newtons. May mga passboard noon na ito yung ginagamit na gamma water. So kung given yan, yan yung gagamitin natin. Okay, so question number 1, compute the volume of the crown. So parang ito yung representation natin. So obviously crown, automatic na lulubog yun since gawa yun sa gold at saka sa silver. So ito yung given yan na weight in air. Kapag weight in air, automatic na ito yung ating actual weight or yung totoong weight ng crown. So, nung nilubog natin siya sa tubig, yung weight niya, that is the weight submerged, naging 12.7 newtons na lang. So, bakit naging 12.7 newtons? 12.7 newtons. Dahil yun sa buoyant force. So, yung case na to, ito yung case na kapag nag-consider tayo ng weight in air, nilagay natin sa tubig, fully submerged siya, mababawasan siya ng buoyant force. Equal yun sa weight submerged. Okay, recall lang natin, anong equivalent ng buoyant force kapag fully submerged? Fully submerged yung object. Ito yung unit weight ng liquid multiplied by the volume of the object. Para masagutan natin si question number 1. Okay, so what is the weight in air? Okay, the weight in air is equal to 14 newtons minus the buoyant force. Ang result nito is yung weight submerged na 12.7 newtons. So magkakaroon tayo dito ng equivalent ng buoyant force equal to, so anong equivalent ng 14 minus 12.7? That is 1.3 newtons. So ano ulit yung equivalent ng buoyant force kapag fully submerged? Okay, equivalent niya is the unit weight of the liquid, the volume of the object equal to 1.3 newtons. So since nasa newtons yung value na sa right side ng equation natin, gagamit rin tayo ng newtons. That is yung 9,790 newtons per cubic meter. Since ito yung given, volume of the object is equal to 1.3 newtons. So, makukompute natin yung equivalent ng volume of the object. That is the same as 1.3 newtons, divided by 9,790 newtons per cubic meter. So, yung naiwan dito is, pwede nating sabihin, that is 1.33, this is times 10 raised to negative 4 cubic meter. Since ika-cancel natin yung unit na newtons. So, do we have this value? 1.33 times 10 raised to negative 4 cubic meter. For problem number 1, yun na yung value na letter. Letter A. So, 0.000133 cubic meter. Then number 12, compute its specific gravity. Number 2. So, sa number 2, paano ba mag-compute ng specific gravity? Magre-recall tayo. So, the specific gravity of any object is the unit weight of any object divided by the unit weight of water, or pwede naman density. The density of any object divided by density of water. So, ang gamitin natin dito is yung density, the unit weight, since weight yung given. Unit weight is equal to the weight of the object divided by the volume of the object. So, ano yung gagamitin natin na weight of the object? Take note na gamitin lang natin yung actual or yung the weight in air, the 14 newtons. So, this is equal to 14 newtons. That is the actual weight of the crown. This is divided by the volume of the object. Na-compute natin na 1.33. This is times 10 raised to negative 4 cubic meter. So, meron na tayong unit weight of the object in terms of the newtons. This is the newtons per cubic meter. I-compute natin yan. So, that is, we have 14 newtons. This is divided by 1.33. This is times 10 raised to negative 4. That is 105,263.15 Check natin. 105,263.158 newtons per cubic meter. Yun yung unit weight ng crown. So ngayon, kunin natin yung specific gravity ng crown. This is the unit weight of the object divided by unit weight of water. So take note na ang specific gravity ay unitless. 105,263.158. Ang unit nito ay nasa newtons per cubic meter. So, yung gagamitin natin na gamma water, the same unit dapat. Pero, gamitin natin yung given. Yung given na 9,790 ay newtons per cubic meter. So, magka-cancel yung mga units since specific gravity ay unitless. So, let's have that value, 105,263.1579. This is divided by gamma water this time is 9,790. That is equal to 10.752. 10.752. The specific gravity of the crown. So, check natin sa number 2, 10.752. Yung pinakamalapit na value is 10.75. That is letter D. So, sa number 3, compute the fraction of the silver in the crown. Diba sa sinabi niya sa problem na yung crown is an alloy of gold and silver. So sa number 3, i-consider lang natin yung mga components. Yung weight ng gold plus yung weight ng silver is equal to the total weight or yung actual weight, which is equal to yung 14 newtons. Diba unit weight is equal to weight divided by the volume. Paano tayo magko-compute ng weight? So, weight is equal to the unit weight times the volume. So, ito yung gagawin natin. Express lang natin yung mga weight ng gold at silver in terms of this equation. Okay? Ano yung weight ng gold? Yung weight ng gold is, meron siyang specific gravity na 19.3 times gamma water. Yung given dito is 9,790 newtons per cubic meter times the volume of the gold. Okay? So, ito yung gamma times the volume. Paano ba tayo kumuha ng unit weight ng object is specific gravity ng object times gamma water. And then plus, sa silver naman, ano yung kanyang specific gravity? Specific gravity ng silver is 10.5. Okay, double check natin yon. So, specific gravity ng gold is 19.3. Specific ng, sa silver naman, specific gravity is 10.5. So, we have, ulitin ko, so it's 19.3 times 9,790, volume ng gold. So, 10.5. Okay, 10.5 times yung gamma water, that is 9,790 multiplied by the volume of the silver is equal to the total weight, which is the 14 newtons. So, pwede natin i-simplify ito, dividing all terms by 9,790. So, magkakaroon tayo dito ng equation. Sabihin ko na lang equation number 1. Ito yung 19.3 volume ng gold plus 10.5 volume ng silver is equal to the 14 over 9,790. So let's say ito yung ating equation number 1. So since volumes na yung mga nandito, ano pa yung isang equation natin na pwede natin gamitin? Okay, kung pagsasamahin natin yung volume ng gold, volume of the gold plus the volume of the silver is equal to the total volume of the object. Yung na-compute natin na volume ng object kanina, yun yung required sa number 1. That is the 1.33 times 10 raised to negative 4 cubic meter. So equal ito sa 1.33 times 10 raised to negative 4 cubic meter. Okay, so let's say this is the volume of the gold plus the volume of the silver is equal to 1.33. This is times 10 raised to negative 3. So let this be our equation number 2. So, to equations to unknowns, ito yung una. Okay, in terms of the weight, nagkaroon tayo ng dalawang variable, volume ng gold tsaka volume ng silver. Yung pangalawa naman is in terms of the volume. Okay, so to equations to unknowns, gagamit na lang tayo dito ng mode equation. So let's say this is mode number 5, number 1. So it's 19.3. Okay, we have 10.5 is equal to 14 divided by 9,790. Tapos, BG 1, BS 1. Total volume is 1.33. This is times 10 raised to negative 4. Okay, so we'll be having the volume of the gold. Yung first variable natin is the volume of the gold. That is 3.81. This is BG is equal to 3.81. This is times 10 raised to negative 6 cubic meter. The volume of the silver is 1.292. This is 1.292. This is times 10 raised to negative 4 cubic meter. 1.292 times 10 raised to negative 1.292 times 10 raised to negative 4 per cubic meter. Pero ano ba yung pinaka-required sa question number 3? Yung question number 3, ang pinaka-required dito is yung percentage daw ng silver. So let's say this is percent silver equal yun sa volume ng silver divided by the total volume of the object. So this is 1.292. This is times 10 raised to negative 4 cubic meter. Divided by ano yung total volume ng crown? The total volume of the crown is 1.33. This is times 10 raised to negative 4 cubic meter. So this is now yung percentage ng or yung fraction ng silver. Okay, so this 1.292 times 10 raised to negative 4. This is divided by the total volume of the crown, 1.33. This times 10 raised to negative 4. Okay, so we have a percentage of 0.971. So ito yung fraction. So mas maraming silver compare sa gold. Kung mapapansin ninyo, mas maliit yung volume ng gold. This is times 10 raised to negative 6. Ito yung percentage ng silver. Check natin sa choices for question number 3. 0.971. We have the closest value 0.97. Letter C. So ito yung case ng buoyancy na yung object ay fully submerged. Okay, so dito tayo sa problem 4 to 6. Ito yung topic na stability of floating objects. A rectangular scow 9 meters wide and 15 meters long and 3.6 meters high has a draft in seawater 2.4 meters. Its center of gravity is 2.7 meters above the bottom of the scow. So number 4, compute the initial metacentric height, determine the final metacentric height, calculate the righting or overturning moment. So ito yung given. Meron tayong rectangular scow, 15 meters long, 3.6 meters high, tapos 9 meters wide. Ito muna yung mga gagamitin natin na term. Yung M is the metacenter, G is the center of gravity, B sub O is the center of buoyancy. Okay, so sinabi niya sa problem, ito yung height, 3.6 meters. Okay, mula daw sa ilalim, yung center of gravity, yun yung G, ay 2.7 meters. Ginamit niya yung term na draft. So sa mga formula, ang ginagamit dito is yung D. Okay, dito yung D, the draft, 2.4 meters. Pero the same lang yan sa, pwede nating sabihin na ito yung height. Okay, height submerged. And one thing more, sinabi niya na hindi ito fresh water. So since hindi siya fresh water, sinabi niya sa problem na seawater ito, gagamit tayo ng specific gravity ng liquid na 1.03. Yun yung specific gravity ng seawater. Tapos, okay, saan natin ilalagay yung mga points na yon? Okay, una, yung metacenter. So, yung metacenter, i-assume natin na nasa taas siya. Ito yung point M, that is the metacenter. Yung center of buoyancy naman, the B sub O, ito yung mid-height nung nakalubog na volume. So mid-height, nakalubog siya ng depth na 2.4 meters. So sabihin natin na yung center of buoyancy or the B sub O ay nasa, okay, ano yung depth na to mula sa ilalim? Kung nakalubog siya ng 2.4, okay, kalahati nito is obviously 1.2 meters. Tapos, okay, 1.2 meters or 1.2 meters mula sa ilalim. Okay, mula sa ilalim ng scow, okay, yung center of buoyancy ay nasa 1.2 meters. Okay, so yun na yung mga points natin. Okay, the metacenter, okay, the center of gravity, and the center of buoyancy. Yung metacentric height na sinasabi niya sa number 4, ay yung metacentric height, ito yung distance mula sa metacenter papunta sa center of gravity. Okay, so kumbaga, sa figure na to, ang sinasabi niya na metacentric height is, ito lang naman, ay mula sa metacenter papunta sa center of gravity. Ito yung M, okay, G. From point M to point G. So, paano ba mag-compute ng metacentric height? May formula tayo for the metacentric height. This is mg is equal to, okay, the mb sub o, okay, plus, or this is minus, okay, minus, okay, the gb sub o. Kapag positive yung ating metacentric height, okay, kapag positive yung lumabas na mg, ibig sabihin yung floating object natin ay stable. Okay, stable siya, which means hindi siya magro-roll. Okay, yung term kasi kapag umikot yung yung isang object along its weaker axis, ang term doon is rolling. Pero kapag umikot naman siya with along its stronger axis or yung longer dimension niya, yung term naman dito is yung the pitching. So, lumubog yung Titanic, yung term sa kanya is pitching since it is along its length. So, kapag along its shorter dimension, yung 9 meters rolling. Kapag along the longer dimension, yung 15 meters, yung term doon is yung pitching. Okay? So, para makuha natin yung metacentric height, okay, paano natin kukunin yung MB sub O? Okay, we have yung MB sub O is basically equal to the moment of inertia of the section considering yung kanyang weaker axis. This is divided by the volume of the draft, or the moment of inertia, this is divided by the volume submerged. Yan. So, kunin natin. I-consider natin dito yung rolling. Okay, since siya yung mas mataas yung chance na mangyayari. So, kung rolling yan, okay, ano yung kanyang moment of inertia? So, yung moment of inertia or yung section na i-consider natin when it comes to the rolling is considering its weaker axis. Yun yung 9 meters. So, yung gagamitin natin na H. Tapos, yung B, ito yung 15 meters. Take note, ang kino-consider kasi natin dito is yung rolling. Considering the weaker axis, yung 9 meters. So, by the way, yung 9 by 15 na yan ay top. That is top view. Okay? So, kunin natin yung equivalent ng MB sub O using yung general formula for any shape. That is the moment of inertia divided by the volume submerged. So, we have the value of the MB sub O is equal to moment of inertia. Meron tayong base na 15. By the way, ano ba yung moment of inertia ng rectangular section? Ito yung BH cubed divided by so that is the moment of inertia. We have a base of 15. Okay, yung depth natin dyan ngayon magiging 9. Yun yung H niya considering rolling. This is cube. This is divided by 12. Okay, divided by, ano yung volume na nakalubog? So yung volume nakalubog is, okay, nakalubog yung height na 2.4 meters. So that is, okay, divided by, yung height na nakalubog is 2.4. Yung dimension ng rectangular scow ay 9 meters by 15 meters. So i-compute natin yung MB sub O. That is 15 multiplied by 9. This is raised to 3. Okay, divided by 12. Ito yung moment of inertia ng weaker axis. This is divided by yung volume na nakalubog is 2.4. Okay, multiplied by 15 multiplied by 9. So we have that as 2 point. This is 2.81, ano yan? 2.8125. This is 2.8125 meters. So that is M, metacenter, papuntang center of buoyancy. So sa figure natin, ito yung MB sub O. Okay, mula sa metacenter, papunta dito sa center of gravity, ito yung distance na M. Okay, ito yung distance na M, B sub O. So, ano naman yung distance mula sa center of gravity papunta sa center of buoyancy? Ito naman yung distance na GB sub O. From center of gravity, papuntang center of buoyancy. So, paano natin kukunin yung distance na mg based sa figure? Yun yung formula na to. So, yung mb sub O, ito yung mb sub O, mb sub O ay minus the gb sub O. Okay, yun yung distance from M to G. Okay, compute natin. So, ano ba yung value ng gb sub O pala? Based sa figure, ano yung distance na to? Mula sa center of gravity papunta, mula sa center of gravity papuntang center of buoyancy. That is 2.7 meters minus 1.2. Okay, yung location ng center of buoyancy. Okay, kunin muna natin yung value ng GB sub O. Okay, center of gravity papuntang center of buoyancy. Di ba yung center of gravity is 2.7 meters mula sa ilalim? Minus yung B sub O or the center of buoyancy. Okay, ulitin lang natin para malinaw. Okay, yung center of gravity is 2.7 meters mula sa ilalim. Yung center of buoyancy ay 1.2 meters mula sa ilalim. So yung distance na GB sub O ay 2.7 minus 1.2. So this is, okay, 2.7, okay, minus 1.2 is equal to 1.5 meters. Okay? So, pwede na natin kunin ngayon yung mg or the metacentric height. Ito yan. So, we have mg is equal to, ano yung ating mb sub O? Na-compute natin siya as 2.8125 minus GB sub O, ang GB sub O ay 1.5 meters. So, metacentric height, mg, is now equal to, tapos 2.8125 minus, ay 1.5. Okay, so meron tayong value dito na 1.3125 meters. Okay, ito na yung sagot natin sa question number 4. Okay, check natin sa choices. 1.3125, that will be letter A. Okay, so sa case naman ng rectangular, ito applicable lang sa 4 rectangular sections. Hindi siya pwede sa ibang shape. Kapag rectangular naman, yung pag-compute natin ng B sub O, pwede natin gamitin itong formula na to. Ito yung B squared, this is divided by 12 times D. Okay, multiplied by 1 plus. Okay, the tangent squared of theta, this is divided by 2. Yan. So, applicable lang siya for rectangular. Yung B na gagamitin natin dito is kung ano yung width na i-consider natin. Ang weaker axis natin is yung 9 meters. Kaya siya yung gagamitin natin na B equal to 9 meters. Tapos yung D natin is yung height submerged, that is 2.4 meters. So, dito sa number 4, wala naman siyang sinabi na may rotation na or may ruling na nangyari. So, kung wala siyang sinabi na rotation, i-assume mo muna yung theta is equal to 0 degree. So kung mag-substitute tayo sa pag-compute ng MB sub O, for rectangular section, MB sub O is equal to 9 squared. This is divided by 12 times 2.4. This is multiplied by 1 plus the tangent of 0 squared. This is divided by 2. So alam natin kapag tangent of 0, ang tangent of 0 is the same as 0. Okay, check lang natin kung parehong MB sub O yung makukuha natin for this case. That is, okay, we have yung B sub O is equal to, okay, that is 9 squared. This is divided by 12 times, okay, 2.4. Okay, so yung lumabas dyan is, okay, pareho lang kanina, the 2.81, 25 meters. So, pareho lang nito kanina yung ginamit natin. Yung ginamit ko kanina na I over the volume submerged, that is for general. Kahit anong shape. So, we arrive with the same value, okay, 2.8125. Okay, then, question number 5 tayo. Dito sa question number 5, determine the final metacentric height when the scow tilts until one side is just at the point of submergence. So, ito naman yung figure natin for question number 5. So, i-rotate daw natin yung scow up to a point na yung isang side niya is at the point of submergence. Ito, parang yung corner niya, mararating na niya yung tubig. Kapag nag-rotate ang object, ang mangyayari sa kanya is lilipat yung ating center of buoyancy. Kaya meron tayong panibagong point ngayon. Okay, that is the B sub O prime. Okay, that is the final point of buoyancy. So, take note for stability, dapat align pa rin yung dalawang ito. Okay, the center of buoyancy at saka yung the center of buoyancy at saka yung center or the metacenter. So, dapat align pa rin yan. So, since nag-rotate siya, magkukos yun ng moment. Okay, ito yung x distance na yan. Ito yung ating metacentric height, the M. Okay, the mg. So, dito magfo-focus yung the weight. Alam natin na yung weight ng object ay nakafocus sa center of gravity. Tapos, yung buoyant force naman is acting at the center of gravity. So, kapag nag-rotate siya, basically, ang mangyayari is kailangan lang natin kunin yung rotation. So, parang ito yung kanyang rotation. Okay, meron tayong free space kanina. Ano ba yung free space sa ibabaw ng tubig? Di ba nakalubog siya ng 2.4 meters? So, ibig sabihin, if the total height of the scow is 3.6, may remaining dito na 1.2 meters. Okay, ngayon, pag rotate natin, ilulubog natin yung 1.2 na yan. So, ito yung 1.2 meters. So, tapos, mula dito, okay, i-consider lang natin yung kalahati yung width ng scow. Yung width ng scow is 9 meters, kalahati niya is 4.5 meters. Ito yung rotation na binigay or nangyari. So, paano natin kukunin yung theta? Okay, we can use tangent since ito yung right angle. That is, the tangent of theta is equal to opposite, that is 1.2 meters, divided by 4.5. So, kunin natin yung angle na yan, that is, sabihin natin shift tangent of 1.2, this is divided by 4.5. That is 14.931. So, we have the value of theta is equal to 14.93 degrees. Okay, so meron na tayong rotation. So, paano ulit kumuha ng MB sub O this time? Or paano ulit kumuha ng MG? Yung MG, ganun pa rin. MG, kaya lang, MG is equal to the MB sub O prime minus the GB sub O. So, kunin natin yung panibagong value ng MG, ng MB sub O. Yung MB sub O prime, since nagkaroon ng rotation, gamitin natin yung formula for rectangular, since rectangular naman yung scow natin. Ito yung Okay, ito yung B squared. This is divided by 12 times D. Okay, multiplied by 1 plus, okay, the tangent squared of theta. This is divided by 2. Since meron na tayong rotation ngayon. So we have the MB sub O prime is equal to 9 squared. Okay, divided by 12 times yung height na nakalubog is 2.4. Okay, this is multiplied by 1 plus, okay, the tangent of yung angle natin is 14.93. So, naka-squared ito. Squared. So, this is divided by 2. So, ano kaya yung magiging value ng MB sub O prime? So, we have that as 9 squared divided by, this is 12 times 2.4. This is multiplied by 1 plus the tangent of 14 ay 0.93. So ito dapat ay naka-squared. Squared. So this is divided by 2. So that is 2.91 to 5. Sabihin natin, this is 2.9125 meters. Yun yung value ng MB sub O prime. Pero ang hinahanap natin dito is the final metacentric height, yung mg. Yung panibagong value ng mg is the MB sub O, that is 2.9125 minus yung GB sub O natin is the 1.5. So we have yung mg is equal to 2.91248 minus the 1.5 is equal to 1.4125. 1.4125 meters. This is the final metacentric height kapag nagkaroon ng rotation. So this is sa number 5, question number 5. 1.4125, ang pinakamalapit na dyan is si letter C. That is 1.41. That is for question number 5. So sa number 6, okay, calculate the righting moment or overturning moment when the scow tilts until one side is just at the point of submergence. So ito yung diniscuss ko kanina regarding dun sa mga points natin. Okay, so tanggalin lang natin yung ibang parts dito. Since nakuha na natin yung angle, pwede na tanggalin yan. So, saan ba nag-a-act yung total weight ng isang object? Okay, yung total weight ng object is acting at the center of gravity. Ito yung weight. So, yung buoyant force naman is nag-a-act dun sa center of buoyancy. Okay, so since hindi sila magkakasalubong dahil nagkaroon ng rotation, di ba, dapat yung center of buoyancy ay naka-align dito sa metacenter. Ito yung distance na na-create. Ito yung distance, x. So, since meron na tayong value ng mg, ito yung from point M to point G, ito yung angle, the angle of theta. Or lipat ko lang yung mg. Okay, ito yung distance from the metacenter to the center of gravity. Paano natin kukunin yung value ng x? Okay, kung ililipat ko lang yung value ng x dito sa taas, yun yung horizontal distance ng center of gravity papunta sa metacenter. Ito yung distance din na x. Tapos, ito yung angle na kinuha natin kanina. Okay, the value of theta. So, kung magmo-moment ako dito sa point G, okay, kung magmo-moment ako dyan sa point G, let's say the summation of moment about point G is equal to 0, clockwise moments to be positive. Okay, that is the same as, okay, parang nag-create siya ng couple. So, yung magnitude ng moment na yun is the same as, okay, the buoyant force, okay, multiplied by yung value ng x. Pero kung i-check natin yung equilibrium, okay, if we are to do summation of forces vertical equal to 0, upward forces to be positive, dalawa lang yung vertical forces natin. Yung weight at saka yung buoyant force lang. So basically, yung buoyant force ay equal lang sa weight. Kaya pwede pa nating i-simplify yung equation na to. Tapos yung x na to, kunin mo natin yung equivalent ng x. Yung equivalent ng x, using yung triangle na to, is equal to, that is, kung gagamit tayo ng function dyan, ito yung sine of theta, opposite, di ba? Ito yung angle theta. Yun yung angle theta, opposite niya yung x, hypotenuse niya yung mg. So, sine of theta is equal to opposite, yun yung x, divided by the metacentric height. So, ang equivalent ng x is equal to the metacentric height mg sine of theta. Kaya minsan sa mga reviewer, may formula na yung moment na to. Yung moment na yan is equal to, anong equivalent ng buoyant force? Equal lang siya sa weight. Anong equivalent ng x? Ito yung metacentric height mg sine of theta. Okay? So that is yung equivalent ng writing or overturning moment. Pero since, kung meron tayong positive na mg, ibig sabihin, stable. Okay, kung stable siya, ibig sabihin yung equivalent ng moment na kinocompute natin ay isang writing moment. Otherwise, kung unstable siya, ang tawag naman doon is the overturning moment. Okay, kunin natin yung weight ng rectangular scow. Paano natin kukunin yung weight nito? Okay, yung kanyang weight is, di ba, buoyant force, tapos weight. Yun lang naman yung dalawang vertical forces natin. Wala nang iba. So, paano ulit kumuha ng buoyant force? Okay, ginawa na natin yun kanina. That is, the buoyant force is equal to, that is the unit weight of the liquid multiplied by the volume submerged. So, take note, seawater ito. And take note na yung buoyant force ay simply equal sa weight. So, we have the buoyant force is equal to the weight. Kapag lumulutang ang object, equal lang talaga yung dalawang yan. Equal yun sa unit weight ng liquid. Take note, seawater, 1.03 times 9.81. Ano yung volume na nakalubog? Nakalubog siya sa depth na 2.4. Yung dimension ng rectangular scow ay 15 by 9 meters. So, ito na yung total weight ng rectangular scow. That is 1.03 seawater times 9.81. This is multiplied by yung volume na nakalubog, 2.4 by 9 by 15. That is equal to 3,273.793. Double check natin. 3,273.793. Okay, so computing for the moment. This is, since positive yung mg, this is a writing moment. Okay, what is the value of the weight? That is 3,273.793. Ano yung ating metacentric height? The metacentric height is, gamitin ko yung nasa choices, those 2 decimal places lang. 1.41. Multiplied by the sine, ano yung angle natin kanina? Yun yung 14, ay 14.93 degrees. So, mg sine theta. Okay? Weight mg sine theta. So, computing for the writing moment equal to, that is the weight, okay, multiplied by metacentric height, 1.41, multiplied by yung rotation, ay 14.93 degrees. Is 1,189.273. 1189.273. Moment ito, so this is kilonewton meter. Okay, check natin sa choices if we have this value, 1189.273. Okay, for question number 6, ay pinakamalapit na sa choices, 1189.3 kilonewton meter. So that is yung sagot natin sa question number 6. So this is a topic, stability of floating bodies. Dito naman tayo sa problem 7.2, 9. Water is being raised from reservoir A to reservoir B using pump as shown. The frictional losses from reservoir A to the entrance of the pump is 3 times its velocity head. while the frictional losses from the exit of the pump to reservoir B is 20 times its velocity head. The total flow is 20 liters per second. Okay, so establish muna natin yung mga given. Okay, ito yung unang sinabi niya na head loss. Yun yung from reservoir A to entrance of the pump. Yun yung A to 1. Ang head loss daw yung head loss daw is 3 times the velocity head. Then, yung from the exit of the pump to reservoir B is 20 times the velocity head. So, alam naman natin yung velocity head, that is the B squared over 2G. Yung given na discharge, ito yan, yung Q, equal to 0.02 cubic meter per second, or ito yung 20 liters per second. So, kakailanganin natin yung mga velocities. Since isang pipeline lang yan, series connection, okay, this is a continuity equation, yung discharge sa 1 is equal to discharge sa 2. So basically, equal to area 1 B1 equal to area 2 B2. So kunin natin yung mga velocities. Okay, so we have the discharge is equal to 0.02. Area 1, ano ba yung diameter ng pipe number 1 pala? Pipe number 1 is 150 millimeters. So this is the same as 0.15 squared pi, okay, divided by 4. This is multiplied by B1. So ano yung velocity of flow dun sa first pipe? Yun yung before the pump. That is the same as 0.02. This is divided by 0.15 squared sheep pi. This is divided by 4. So that's equal to, let's say, 1.132. This is 1.132 meters per second. Then yung second pipe, so we have the same discharge of 0.02. Yung diameter ng second pipe is 100 mm or 0.100 squared pi divided by 4. This is multiplied by velocity number 2. So kunin natin yung velocity of flow dun sa second pipe. So that's the same as 0.02 divided by 0.1 squared sheep pi. This is divided by 4. So we have the velocity of flow dun sa second pipe is, sabihin na lang natin, this is 2.546 meters per second. So kunin natin yung mga velocities, yung mga head losses based dun sa sinabi niya sa problem. So this is the same as we have 3. Yung velocity sa pipe number 1 is 1.132 squared. This is divided by twice of 9.81. So 3 times the velocity head. Yun daw yung value ng head loss sa pipeline number 1. Okay, so we have head loss 1. So this is the same as 3 times the velocity head. That is 1.132 squared. This is divided by 1.132 squared divided by twice of 9.81. So we have our first head loss is equal to 0.196. This is 0.196 meter. That is head loss number 1 from A to 1. Head loss number 2, this is, we have 20, multiplied by the velocity head. Yung velocity sa number 2 is 2.546. So this is, multiplied by 2.546 squared, divided by twice of the 9.81. So ito naman yung head loss ay doon sa pipeline number 2. So we have that as 20, multiplied by, we have 2.546 squared. So it's divided by twice of 9.81. So we have that as 6.608. This is, let's say this is 6.608 meters. So that will be the head loss 1 and head loss number 2. So we are now to answer the first question, that is question number 7. I compute the output power of the pump. So to determine the output power, we need to determine the head output of the pump. Okay, to compute for the head output, we are to use the energy equation. So starting with A, we are considering the points. Let's say that is from reservoir A to reservoir B. Okay, so we have to consider the energy at A and the energy at B. Take note that A is an open reservoir. If it is an open reservoir, with an elevation, so we are to start with elevation. So elevation 1, that is the same as 0 based on the given. After the elevation head, we have the pressure head. Let's say that is the pressure at 1. Or let's say, I'll be using, the elevation at A is equal to 0, based on this given. The pressure at A, open reservoir. So kapag open reservoir, that is 0 pressure. Tapos, kapag malaking area ng tubig or hindi naman given yung area ng reservoir A, kahit nababawasan ng tubig yan, i-assume natin na hindi gumagalaw yung liquid surface. So, i-assume din natin na yung velocity head sa A, ito yung parang BA squared divided by 2G is the same as 0. So, walang energy head sa A, 0 yung elevation, 0 yung pressure, 0 yung velocity head. So, kung gagawa natin siya ng energy grade line, supposedly, that is expected to be horizontal sana. Kaya lang, nagkakos yun ng head loss. Since meron tayong head loss from A to 1. So, let's say, ito yung head loss number 1. So, for example, yung energy level, na remaining dito sa energy grade line, ay nasa level na to. Okay, ano yung gagawin ng pump? So basically, ang gagawin ng pump is itataas niya yung energy head. Okay, so ang gagawin ng pump, itataas niya yung energy head. Let's say dapat yung energy head na is mas mataas kay reservoir B para umabot yung tubig kay reservoir B. Let's say this is the head output or the head added by the pump. Then, gawa lang ulit tayo supposedly ng horizontal line towards reservoir B. Then, habang magpo-flow yung tubig from the pump to reservoir B, again, magkakaroon ulit tayo ng head loss. So, let's say, from the pump to reservoir B, this is head loss number 2. Okay, recall naman natin yung mga energy heads na meron kay B. So, meron tayong elevation head kay B that is given 240 meters. Open reservoir rin si B, kaya yung pressure is equal to 0. I-assume natin na malaki yung surface area niya, ay hindi gumagalaw yung liquid surface. So, we assume that the velocity head at B is also equal to 0. So, normal yun for reservoirs. Okay? Na yung velocity head at saka pressure head ay 0. Ngayon, kung gagawa natin ito ng energy equation, okay, parang pwede tayong magsimula kay A. This is the energy at A up to B. So, starting with the elevation head at A, plus the pressure head at A, plus the velocity head at A. Okay, so ito yung total energy head sa A. Kaya lang, bababa dahil nagkaroon ng head loss. So that is minus head loss number 1. Pero ano yung ginawa ng pump? Itataas niya. So that is plus the head added by the pump. And this is now equal to, yung height na to, dun sa tuktok ng energy head ng pump is equal to the head loss number 2. Okay, plus the velocity head at B, reservoir B, plus the pressure head at B, plus the elevation head at B. So ito yung parang complete energy equation natin. Pero para ma-simplify, ano yung mga zero dito? 0 yung elevation sa A, 0 yung pressure, 0 yung velocity head. So ang naiwan is negative head loss plus the head added by the pump is equal to kapag reservoir velocity head ay 0, pressure head ay 0. Okay, and ang naiiwan dito is yung head loss dito sa right side ng equation. That is the head loss number 2 plus the elevation of reservoir B. Okay, gamitin natin yung equation na to compute for the head added by the pump. Okay, that is for question number 7. So yung natirang equation doon is the negative head loss. Supposedly head loss 1 yon. Negative head loss number 1 plus yung head added by the pump is equal to head loss number 2 plus elevation of reservoir B. Okay, mag-substitute na tayo. Okay, so this is equal to the negative head loss. Ano yung head loss number 1 natin? That is 0.196 plus the head added by the pump is equal to head loss number 2 natin is 6.608 plus ano yung elevation ni reservoir B? Ang given ay 240. So ito yung head added by the pump. The same as head output. And is equal to that is 240 plus 6.608 ay plus 0.196. That is 246.804. Ay 246.804 meters. Okay, the head added by the pump or the same as the head output. Okay, paano kumuha ng power output? The power output is the same as the unit weight of water plus times the discharge, okay, multiplied by the head. Kung power output, gamitin natin yung head output or head added by the pump. Ay, yung unit ng nasa choices ay nasa kilowatts. So, ang gagamitin natin dito is kilonewton. So, this is we have the power output is equal to 9.81. This is in terms of the kilonewtons per cubic meter. Yung discharge ay 0.02 cubic meter per second. Yung head output is equal to 246.804 meters. Kung mag-unit analysis tayo dyan, cancel na yung cubic meter. So, we have the power output is equal to, so ang naiwan na unit is the kilonewton meter per second. Pareho lang ito sa kilowatts. Okay, compute natin yung value. So this is multiplied by the head output times 0.02, the discharge times gamma water, 9.81. So this is equal to 48.423. So this is 48.423 kilowatts. Okay, check natin kung meron yan sa value sa choices sa number 7. 48.423. Okay, ang pinakamalapit na sa choices, we have 48.42 kilowatts. So that is, okay, for problem number 7. Okay, then, dito tayo sa number 8. Compute the pressure head at 1. Okay, so paano naman natin i-compute yung pressure head sa point 1? I-consider lang natin, pwede tayong mag-consider ng 2 points ulit. Then, gawa natin ang energy equation. So, let's say this is from A to 1, yung entrance ng pump. So, nagawa naman natin to kanina. I-consider lang natin yung mga elevation. So, elevation ni A is 0. Yung pressure head ni A ay also 0. Yung velocity sa A is also equal to 0. So, yun yung mga energy heads sa point A. Ngayon, okay, supposedly yung energy grade line is ay bababa sa direction of flow. So, let's say ito yung energy grade line from A to 1. Okay, bumaba yung energy grade line dahil yun sa head loss sa 1. Okay? So, ano naman yung mga remaining energy heads dito sa 1? So, nandito yung kanyang elevation. Yung elevation ni 1, the elevation of point 1 is negative 20 meters. Okay, mas mababa siya ng 20 meters kaysa kay A. So, kakailanganin din natin dito yung kanyang pressure head. Yun yung P1 over gamma, which is yun yung required. At saka yung kanyang velocity head, the V1 squared over 2G. So, ito yung mga kailangan natin. Okay, we have the elevation head. pressure head at saka velocity head. At saka yung head loss number ay number 1. Ngayon, kung gagawa natin yan ng equation, ito yung total energy head sa A is Z sub A, elevation head, plus the pressure head, plus the velocity head, B sub BA squared over 2G. Yun yung total energy head dito sa A, equal to, saan tayo magsisimula, yun yung head loss number 1, pababa, plus the B1 squared over 2G, plus, we have the P1 over gamma, plus yung kanyang elevation, the C sub 1. Pero for a reservoir, this is 0, 0, 0. Ayun. So, ang hinahanap natin ay pressure head. That is the P1 over gamma. Okay, then substitution. So, this is 0. Ano yung head loss number 1 kanina? Yun yung 0.196. Plus, ano yung B1 kanina? The velocity at 1. So, head loss number 1 is 0.196. B1 is 1.132. So, that is, we have 1.132. This is squared, divided by twice of 9.81. Yun yung velocity head at 1. Tapos, yung hinahanap natin ay pressure head, that is plus P1 over gamma, plus, ano yung elevation ni point 1? Ang elevation niya ay nasa negative 20. Okay? So, what will be the equivalent of the pressure head at 1? The P1 over gamma. So, ita-transpose natin. So, magpa-positive na yung 20 pagka-transpose. So, this 20, magne-negative naman yung dalawa. Minus 0.196 ay minus ay the 1.132 squared. This is divided by twice of the acceleration due to gravity. That is 19.739. So we have 19.739 meters. So that is the velocity head, pressure head. The pressure head at point 1. That is the pressure head before, at the entrance of the pump. Check natin if we have 19.739 is on the choices, number 8. So 19.739, closest value is letter B, 19.74. So number 19, compute the pressure head at point 2. For number 9, compute the pressure head at point 2. So, pwede tayong mag-consider ng 2 points ulit. So since meron na tayong details kay point 1 kanina, pwede na natin gamitin yung point 1. I-consider ko lang. Pwede natin i-consider yung 1, 2. 1 to 2. Actually, kahit pwede rin naman A to 2, pwede naman 2 to B, at saka yung 1 to 2. Basta, i-consider nyo lang yung mga energy heads. Yung velocity head, pressure head, saka elevation head, at saka yung head loss kung meron. Okay? So, ano yung mga i-consider natin dito kay point 1 saka point 2? Kung magsisimula ako dito kay point 1, nandun yung kanyang elevation head, Z1. So, after ng kanyang elevation head, is yung kanyang pressure head, the P1 over gamma. Then, the velocity head, that is the B1 squared divided by 2G. Tapos, yung pump kasi nandito sa gitna nila. Anong gagawin ng pump? Itataas niya yung energy head. So, ito yung head added by the pump. Tapos, ano yung mga available energy head dito kay point 2? So, nandun din yung kanyang elevation head. Okay, sa ibabaw nun, yung pressure head, the pressure head, at ito na tayo ngayon, the P sub 2 over gamma, at saka yung kanyang velocity head, the B sub 2 squared over 2G. Take note na magkalapit lang si point 1 at saka si point 2. Kapag magkalapit lang yung dalawang point, magne-neglect tayo ng head loss. Okay. So, kung gagawa natin yan ng equivalent energy equation, starting at point 1, this is from 1 to 2. Ito yung Z1 plus the P1 over gamma plus the B1 squared over 2G. Take note na yung pump ay nasa gitna nila. So, plus the head added by the pump is equal to yung total energy head sa point 2. Ito yung B sub 2 squared divided by 2G plus the pressure head at 2 over gamma plus the elevation of point 2. Again, wala tayong kinonsider na head loss since wala tayong details dun sa pump at saka magkalapit lang yung dalawang point. So, pwede nating i-assume negligible yung head loss sa pagitan ng point 1 at saka ng point 2. So, ano yung elevation ni point 1? Ang elevation ni point 1 is negative 20. Okay, plus, ano yung ating pressure head kanina? Yung pressure head 1 kanina is yung 19.739 meters. Ayun ba yan kanina? 19.739 for question number 8. Yes, that is 19.739. Okay, plus the velocity head at 1, ito yung 1.132 squared divided by twice of 9.81. So yung B1 kanina is 1.132. Okay, plus the head added by the pump. Ano na nga ba yung head added by the pump? That is the 246. That's 246.804. So ito ay 246.804 meters. Is equal to B sub 2. Velocity number 2 kanina is 2.546. This is squared divided by twice of 9.81. Ang hinahanap natin dito is the pressure at pressure head at point 2. Ito yung P sub 2 divided by the gamma. Okay, plus ano yung elevation ni point 2? Pareho sila ni point 1 nasa elevation negative 20. So, since equal elevation naman pala, pwede nating tanggalin na yon yung negative 20. Okay, so, computing for the pressure head at 2, this is the equivalent of the pressure head at 2 over gamma. Okay, so this is the same as we have 19.739 plus the 1.132 squared. This is divided by twice of 9.81. And then plus 246.804. Okay, then ibabawas natin yung velocity head mula sa kabila. That is minus the 2.546 squared. This is divided by twice of 9.81. That's 266.278 equal to 266.278 meters. Tama ba? Okay, 266.278. So let us check this value sa choices. Question number 9. Ayan, so closest value we have letter C. That is 266.27 meters. Ito na yung solution natin for 7-2. Okay, problem 7-9. Try naman natin si problem 10-12. This is a water hammer. So water from a reservoir flowing through a pipe with a diameter of 600 millimeters at 1.8 meters per second is completely stopped by a bulb situated 150 meters from the reservoir. The pipe has a thickness of 20 mm. The modulus of elasticity of the pipe is 1.4 times 10 raised to 11 pascals. Okay, the bulk modulus of water is 2.2 times 10 raised to 9 pascals. Assume that the pressure increases at uniform rate and there's no damping of pressure wave. Okay, number 10. So which of the following gives the celerity of the pressure wave? Okay, so for example, ito yung reservoir. So sabi niya at a distance of 150 meters, nandun daw yung bulb. Yun na yung length ng pipe na i-consider natin, 150 meters. The diameter is 600, thickness is 20. Tapos yung E at saka ito, minsan daw hindi given ito, the bulk modulus of water. So paki-memorize. So sa water hammer pressure, meron tayong two cases. Yung una is yung kapag meron tayong rigid pipe. Ay, paano mag-compute ng celerity kapag rigid pipe? Yung celerity is the square root of, that is K divided by the density of water. Or minsan, kung sa ibang reference, ito yung beta over the density. That is for rigid pipe. Yung isang case naman is yung the non-rigid pipe. Kapag non-rigid pipe, that is yung equivalent ng celerity is equal to the square root of the bulk modulus of water. This is divided by the density of water. Okay, multiplied by this is 1 plus the pipe diameter, okay, the bulk modulus of water divided by the modulus of elasticity of the pipe times the thickness. So may mga cases sa board exam na hindi niya sinasabi kung rigid or non-rigid. Pero ang clue ninyo kung rigid siya or non-rigid pipe is kapag kompleto yung given. Kapag kompleto yung given, more likely it is a non-rigid pipe. So kapag hindi kompleto, more likely a rigid pipe naman. So dito tayo sa non-rigid pipe. So kung paki-memorize itong formula for direct substitution, so we have that is the celerity or yung velocity ng sound na dadaan dun sa tubig is equal to, we have, this is the square root of 2.2, this is times 10 raised to 9 all over. We have the density of water is 1,000, ay multiplied by 1 plus, ay yung diameter ng pipe is 600 millimeters, yung K is 2.20 times 10 raised to 9 pascals. Ay all over, yung E naman is ay 1.4 times 10 raised to 11 pascals, yung thickness is ay 20 mm. Kapag nag-unit analysis kayo dyan, lahat ng unit ay magka-cancel dito sa loob ng dalawang bracket. So, computing for the celerity, this is the square root of, we have 2.2, this is times 10 raised to 9, okay, divided by density ng liquid, so tubig yan, so 1,000. Okay, multiplied by, that is 1 plus, the pipe diameter is 600. Okay, the bulk modulus is 2.2 times 10 raised to 9. Okay, divided by the modulus of elasticity ng pipe. This is 1.4 times 10 raised to 11. Okay, multiplied by the thickness of the pipe. This is 20 mm. Okay, so computing for the celerity, that is equal to 1,222.76. So you have the value of C is equal to 1,222.761 ay meters per second. Ito yung velocity ng sound na dadaan dun sa tubig. Is 1,222.76. Okay, check natin yan for question number 11. So we have that as letter B ay 1,222.76 meters per second. Number 11, which of the following gives the composite bulk modulus of elasticity of the pipe and water? So kapag kukunin natin or gagawin nating composite, yun yung tanong niya sa number, ano yan? Is that number 11? Number 10, number 11. So sa number 11, gagawin lang natin siyang rigid. Okay? Yung tanong sa number 11. So, gagawin lang natin siyang rigid using yung na-compute natin na celerity dun sa number 10. So, ano yung sagot natin sa number 10? Ito yon. Yan yung gagamitin natin, pero i-analyze na lang natin siya as rigid pipe. Ano yung magiging equivalent composite bulk modulus of elasticity? So, this is the square root of, we have yung K divided by the density. So, gamitin natin yung nakuha natin na value ng C sa number 10. Yun yung 1,222.761 is equal to the square root of K. Ito na yung K na to, ito na yung composite bulk modulus divided by the density of water na 1,000. So this is now the composite bulk modulus of the water and the pipe. So we have that as 1,222.761 squared times 1,000. Okay, so ilang digits ito? So we have 3, 6, 9. So yung lumabas is we have 1.495. This is times 10 raised to 9 Pascal. Check natin if we have this value, the 1.495 times 10 raised to 9 Pascal. So 1.495, okay, masasabi ko na yung pinakamalapit na value is we have letter C, 1.5 times 10 raised to 9 Pascal. Then we have number 12, which of the following most nearly gives the water hammer pressure assuming the instantaneous closure? So pag instantaneous closure, sa number, this is number 12, kapag instantaneous, yung time to close yung bulb is, sabihin natin, instantaneous masyadong mabilis, approximately equal to 0. Paano tayo nagko-compute ng pressure? Yung pressure will be equal to the density of the water, the velocity of flow, times the celerity. So ito yung formula natin for the computation of the maximum pressure kapag instantaneous closure. Masyadong mabilis, approximately equal to 0. So we have the maximum pressure at the bulb. Ito yung pressure dun sa bulb. Pagkasara mo ng bulb na to, tataas yung pressure and parang linear yung kanyang function. So parang ganito yung appearance niya. Nandito yung maximum pressure. Habang papalayo ka dun sa bulb, okay, humihina yung pressure. Okay, compute natin. So, the velocity of flow, ano pala yung velocity of flow na given? Okay, yung velocity of flow na given is the 1.8 meters per second. Yun yung velocity of flow ng tubig. Okay, compute natin. So, we have Pmax is, okay, the density of water is 1,000 kilograms per cubic meter. Yung velocity of flow na given is 1.8. Multiplied by yung celerity is 1,222.76. Kung mag-unit analysis kayo, ang lalabas na unit nito ay nasa Pascal. Okay? Kung i-convert natin siya sa, ano ba yung nasa choices? Megapascals. Diba? So, pascals to megapascals. This is multiplied by 1 megapascal is to 1 times 10 raised to 6 pascals or 1 million pascals. Okay, para yung magiging final answer dito, okay, for the maximum pressure is simply in terms of the megapascal. Okay, computing for the maximum pressure at instantaneous closure, that is density of water 1,000, velocity of flow is 1.8, tapos the celerity is 1,222.76. 761. May 1 yata to kanina. Okay, that is, okay, ano to? 2,200,969.8. That is in terms of Pascal. Divided by 10 raised to 6 or divided by 1 million para maging megapascals. At 10 raised to 6, it should be 1 times 10 raised to 6. Hindi 10 raised to 6. So, magkaiba yun. Okay, ulitin natin. That is 1,000. This is multiplied by 1.8. Okay, multiplied by 1,222.761. Again, this is Pascal. Okay, divided by 1 million. 1 times 10 raised to 6. So, that is 2.2. Let's say 2.201 megapascal. Check natin sa choices kung meron tayong value nito. 2.201 megapascals is, okay, pinakamalapit na sa choices is we have letter B, 2.20 megapascal. I think sa board exam ng civil engineering, 2 beses na itong lumabas. Yung water hammer pressure. Okay, try naman natin. Problem 13 to 15. So, water is being discharged. So, Q is equal to 280 liters per second from a reservoir through a turbine as shown. So, assume C equal to 120 for all pipes. Number 13, compute the total head loss due to friction. So, since ang given is C, gagamit tayo dito ng Hazen-Williams. Okay, this is for question number 13. The Hazen-Williams formula for head loss is equal to 10.67. The pipe length, discharge raised to 1.85. This is divided by yung C raised to 1.85. Pipe diameter raised to 4.87. Kaso nga lang sa mga lumang reference or sa ibang reference, minsan hindi siya 10.67. Minsan may gumagamit ng 10.64. Meron din gumagamit ng 10.66. Pero, if you are to derive this one from its original form, yung formula, ang lalabas talaga ay 10.67. Okay? So, kunin natin yung total head loss due to friction. Take note, meron tayong dalawang pipe. So, isa-sum up lang natin or i-add lang natin. So, we have the head loss due to friction is equal to 10.67. Yung first pipe natin is 50 meters. Okay, the discharge is 0.28 or 280 liters per second or 280 cubic meter per second. This is raised to 1.85. I divided by the pipe constant, 120. This is raised to 1.85. Pipe diameter nung una is 300 millimeters or 0.3 raised to 4.87. Okay, plus yung second pipe natin, we have 10.67. The length is 20 meters. Pareho lang yung discharge. 280 liters per second or 0.28 cubic meter per second. I raised to 1.85. This is divided by 120 raised to 1.85. Pipe diameter is 0.6 raised to 4.87. Okay, so computing for the head loss or the total head loss. The head loss due to friction. This is 10.67 multiplied by 50. Multiplied by 0.28. This is raised to 1.85. Divided by 120 raised to 1.85. Pipe diameter nung una is 300 mm. 0.3 raised to 4.87. Okay, yun yung una. Then yung second is plus 10.67. The length of the second pipe is 20 meters. Pareho lang yung discharge in series connection. Okay, 0.28. This is raised to 1.85. Okay, to be divided by 120 raised to 120 raised to 1.85. Okay, to be multiplied by the pipe diameter. Second pipe is 600. Okay, raised to 4.87. That is 2 point. Okay, the total head loss due to friction is 2.572 meters. Okay, so check natin yung value na to sa choices for question number 13. Okay, so wala. Pero yung pinakamalapit sa, ayun, nakuha natin na value kasi is 2.572. Pinakamalapit na is si 2.56. So, hindi natin alam kung ano yung ginamit. Is it the 10.64 or the 10.66? So, pero again, yung actual value should be 10.67. Pero kung ako yung sasagot dyan, letter B yung sagot ko, 2.56. And number 14, I compute the energy exerted by the turbine to generate 56 kilowatts of power. So, nagbigay siya sa number 14 ng power. Okay, the magnitude of the power from the turbine is equal to 56 kilowatts. Paano ba mag-compute ng power? Equal yun sa unit weight. Kung tubig, the unit weight of water. Discharge, then the head. Kung power from the turbine, gamitin natin yung head extracted by the turbine. Okay? So, 56 kilowatts. Ano yung equivalent ng 56 kilowatts? Pareho lang ito sa 56 kilonewton meter. Okay, 56 kilonewton meter per second. So, para consistent sa unit, gamit tayo ng 9.81 kilonewtons per cubic meter. The discharge is 0.28 cubic meter per second. Then, the head extracted by the turbine. So, H sub T natin ay equal sa, that is 56. This is divided by the 9.81. Then, okay, 0.28. That is 20.387 ay 20.387 meters. Ito yung head extracted by the turbine para may power or energy generated, 56 kilowatts. Okay, check natin sa choices. Number 14. Okay, closest value is 20.39 meters. Letter A. Number 15. So compute the elevation of the water surface in reservoir A that would require the turbine to generate 56 kilowatts of power. So sa reservoir analysis, ay alam natin na dapat yung difference in elevation from the source reservoir papunta dun sa receiver na reservoir ay automatic na head loss. Ito yung total head loss. Kaya lang, yung head loss na to, ano yung mga components niya? Yung head loss na to ay may component na due to friction, H sub C. Pero kapag meron ka pang turbine, take note na yung head extracted by the turbine is considered as head loss. So ito yung equivalent ng total head loss. So based sa figure natin, paano natin kukunin yung elevation ni A? Dito ko na lang ilagay. So we have number 15, ang elevation ni reservoir A ay equal sa elevation ni reservoir B plus the total head loss. So gawin natin, that is, elevation ni B is 50 meters plus yung total head loss, ano yung head loss due to friction kanina? 2.572. This is 2.572. Take note na yung head extracted by the turbine is also head loss. H sub T, ano yung H sub T natin? 20.387. So this is 20.387 meters. So parang ganito lang. Mula dito sa surface ni B pataas. Dinagdag lang natin yung total head loss, friction, at saka yung turbine. So we have now the elevation of reservoir A is equal to, this is 50 plus 2.572 plus the 20.387. That is 72.959, 72.959 meters. So ito na yung elevation ni reservoir A. Check natin sa choices. 72.959. Okay, pinakamalapit na sa choices natin, we have letter B. That is 72.95. So may konting discrepancy lang because maybe dahil sa kung ano man yung ginamit nung gumawa ng problem, okay, dun sa formula ng head loss. This is our solution for 13 to 15.